Suppose you're tired of all the digital world and all the apps and technology, and you decide to walk or swim towards the Arctic Ocean in the North Pole without any gadgets and find peace over there. I have one question for you. How would you reach there without any gadget? Well, you say, all I need is a compass. A compass will tell me where the North Pole is. But even if you had an awesome compass and you followed it exactly, you will not reach the North Pole at all. You'll completely miss it. Why? Well, let's find out. So to solve this mystery, let's first start by asking ourselves some fundamental questions about the Earth. First of all, what do we even mean by the poles of the Earth? Well, we know the Earth spins around its own axis. And so wherever this axis touches the surface of the Earth, those are what we call the poles. So there are 2 points. One near the Arctic Ocean is called the North Pole. And the one in Antarctica is called the South Pole. Okay, but what's this got to do with your compass? Why does the magnetic needle always align along the north and south? Well, that's because, and this is something you may have already learned earlier, that's because Earth itself behaves like a giant magnet. You may have seen pictures which show the magnetic field lines of Earth. Now, we're not exactly sure how the Earth is able to generate the magnetic field, what causes it. There are theories out there, but we don't have a conclusive answer yet. But for the purposes of this video, let's just assume that there is a giant bar magnet inside the Earth, okay? Although there isn't, it just makes our life much easier. So here's a question for you now. We now know that the North Pole of our needle gets attracted to the north of our Earth, right? And we're now imagining that there is a bar magnet inside the Earth. So my question to you is, which pole of that bar magnet is in the North Pole of the Earth? Is it the South Pole of the bar magnet or the North Pole of the bar magnet? Can you pause and think about this for a while? All right. Well, we know that north is always attracted towards the south. And since the north is pointing towards the North Pole, there must be the South Pole of the bar magnet over there. And therefore, if you visualize the bar magnet, it's kind of reversed. Does that make sense? Because the North Pole of our needle is attracted to the North Pole, that means the South Pole of the magnet should be at the North Pole. Long story short, Earth's North Pole kind of behaves like a South Pole of a giant bar magnet inside of it. Okay, so if we digest all of this, this means we can use our compass and to help us find where the North Pole of our Earth is. So now we come back to the original question. I said that if you were to just walk with your compass, you will not end up at the North Pole. Why did I say that? Well, that's because there's a small thing that I haven't mentioned over here. It turns out that the axis of the bar magnet does not exactly align with the Earth's pole. In fact, it's tilted a little bit like this. This means the South Pole of that giant hypothetical bar magnet inside the Earth is not exactly in the Arctic Ocean. It's not exactly over here, but it is somewhere shifted. And I Googled it. It turns out about 400 kilometers shifted somewhere in northern Canada. And so now you can see the problem. Let's say this is you who wants to swim to the Arctic Ocean. Then this is the path that you want to take towards the North Pole, towards the Arctic Ocean. But if you follow your compass, it will not lead you over there. It will lead you somewhere over here. You'll end up taking this path and you will miss the North Pole. And so this place where you would reach now, this place is called the Earth's magnetic North Pole. This is called the Earth's magnetic north. And the actual north, the north what we mean, is often called the geographic north, or people often say true north. You can also call this true north. Now you might feel a little uncomfortable, and I do as well, in calling this magnetic north because really it's magnetic south. And so there is a confusion. There's a lot of confusion out there. Some people say, hey, if we call this as the magnetic south pole, then the magnetic south will be close to the true north, and that's going to be confusing. But some people say, hey, if you call this magnetic north, but the field lines are entering over there, so it should really be the South Pole. So you know what? Let's not worry too much about this. Nobody's gonna question you. What is it really called? All that matters is this behaves like the South Pole of a giant bar magnet. Okay, that's all that matters. Okay, so don't worry too much about the confusion. Anyways, let's come back to our point. You need to swim to the Arctic Ocean, right? How do we make sure that you end up over there? Well, all you need is the correction factor. If you can get this angle between the true north, the path to the true north, and the path to the magnetic north, if you can get that angle, then you're done. You can course correct yourself. If this angle was, say, for example, 2 degrees to the east, and if you knew that, right, then what you would do ideally is you would look at the compass and you would say, okay, I don't want to move this way. I need to move 2 degrees east of this, and then you would be on the right path. Okay, so this angle is super important for navigation, and we give a name to that angle. We call that magnetic declination. I know it's a little crowded, so let me write over here. It's called magnetic declination. Okay, we are not done yet. So before we continue, let's check your understanding. Do you think the value of magnetic declination would be the same at everywhere on the planet? Or do you think it will change from place to place? Why don't you pause the video and think a little bit about this? Okay, all I have to do is pick another point and see what path would my compass lead to and what path I would really need to go. And to make things easier, what I'll do is I'll consider a point somewhere over here. Now, if you were to use a compass, well, you will end up going this way. This is the path. But where do you really want to go? If you want to go to the North Pole, this is the path that you need to take. And so now this would be the new angle. I don't know if you can see that, hopefully. And you can immediately see that angle is different than this angle. In fact, that angle is larger than this angle because you're already a lot off course over here. And so clearly you can see that the value of magnetic declination keeps changing, and it has different values at different places, which means it's not like you can look at, at one place and you can say, I know the magnetic declination value, now I'm on the right track. No, you'll pretty soon go off track if you just use that value everywhere. So you have to constantly keep updating yourself, constantly keep looking what the new magnetic declination is at every point, and constantly keep course correcting yourself. So a quick question you might have is, how do we record the declination values everywhere on the planet? How do we write it? How do we communicate that? How do I use it? How do I read that? Okay. So this is where graphs are super important. So there are graphs drawn. We'll not get into too much detail. You can do the research, but let me quickly show you what it will look like. So here's the world map, and all these lines represent a particular declination value. For example, if you are somewhere over here, then you are on this green line. And the green line represents 0, meaning it says at this point, the declination is 0. And then you walk somewhere and maybe you are now somewhere over here. Now you are on this blue line. And notice this blue line says declination value is -10. They have some notation, maybe I think towards the east is called negative, towards the west is called positive or something like that. But so if you look at this map, anywhere you are on the world, you can figure out what the declination value is by looking at which line you are on. All right, again, let's not worry too much about that. So there are ways in which you can figure, these maps help us know what our declination values are. All right, the last thing I want to do before winding up the video is some formalities for your exam. How do you define the magnetic declination angle? Right now, so far we said this path, the angle between this path and this path is the magnetic declination, and that's fine for me. But in physics, we need to have very precise, definitions. So how would you put this in words? Can you pause the video based on whatever you just learned? Can you think about how would we put this in words? All right, maybe you would say something like, okay, it's the angle between the line joining the, your point where you are at, or the point on the Earth, and the true geographic north, and the line joining the point on the Earth and the magnetic north, right? Looks fine. And again, I would give full marks for that. But there's a problem. The word line, is causing problem because, in physics or in maths, line means a straight line. And when you're drawing a line on Earth, it's curve. So you can't just say a line. The second problem is, I can draw multiple lines from here to the true geographic north. I can draw some random line like this, right? So how do you represent this line, the line along the longitude? Okay. Maybe you might say something like, okay, maybe the shortest line between this, let's stop. I'll just tell you how we define it. Instead of calling this a line, that's the only problem we have. Instead of calling this a line, if you were to complete that path, go all the way around the world, what shape would you end up with? Well, you can kind of visualize, you will end up with a circle. And although it doesn't look like a circle, hopefully if I slice the Earth along that path, you can kind of see This is a circle. It's looked, a circle looked at from a side. Okay. So we could say it's the angle between this circle. And how do you define this circle? We could say it's the circle that passes through the point on the Earth and the Earth's, true north and true south poles. Or you can say it has the Earth's axis as the diameter. Okay. So this is one circle we can use to define. And similarly, we can have another circle. For that, you walk along this path, what your compass shows, and again, complete that entire journey. And now you would get another circle. Again, this is a circle. Okay, if I were to slice the Earth, now, you slice it this way. This is what it looks like, another circle. And how do you define this circle? Well, we could say this is the circle that passes through the point where you are standing, or the point on the Earth where we're calculating the declination values, and the Earth's magnetic north, and there will be a magnetic south somewhere down there. Magnetic north and magnetic south poles. Or you could say it's the circle that passes through this point on the Earth and the Earth's magnetic axis. You can call this as the magnetic axis. And we could now say declination is the angle between these two big circles. And because these circles are so useful in definition, we give names to these circles. This circle is called the geographic meridian. Both circles, such circles are called meridians, by the way. So this is called geographic meridian. And this circle, the other circle, because it's along the magnetic, let's use light color. Because it's along the magnetic, we call this light color. Okay, we call this the magnetic meridian. Magnetic meridian. Okay, fancy names are being used, but you get the idea, right? What these two are. And so what's magnetic declination now? We could say magnetic declination is the angle between the geographic meridian and the magnetic meridian. And if anybody asks what exactly is a geographic meridian, it's this. For geographic meridian, you can just imagine the longitude circle at a particular point. And the magnetic meridian is something very similar, but this circle has the Earth's magnetic axis as the diameter. Okay, it passes through the Earth's magnetic axis. So to quickly summarize, we saw that if you just use your compass, it doesn't show the true north pole. And so there is a correction factor required if you want to navigate properly, and that angle is called magnetic declination. The value of the declination changes from place to place and also from time to time, actually. Again, let's not worry too much about that. And how do you define the magnetic declination? We say it's the angle between, or the acute angle, because there are two angles actually, the acute angle between the geographic and the magnetic meridian. And finally, what exactly are these meridians? Well, geographic meridian is a circle. It's basically the longitude circle. It's a circle that has it passes through the geographic north and south poles. And if you just say that, you can draw many circles, right? And the point at which you're calculating the magnetic declination. Similarly, what's the magnetic meridian? It's a circle that passes through the Earth's magnetic north and south poles and the point at which you're calculating the magnetic declination. So the angle between them is the magnetic declination.